The title and aim of this paper is Coactivation Detection in 10-finger typing on a virtual keyboard. One factor that has contributed to the slow adoption and use of virtual and augmented reality is the lack of a reliable high-throughput input method. Adapting the concept of a common keyboard to create a virtual keyboard is one way of tackling this problem, but this exposes a challenging input interpretation problem with many sources of noise. One particularly challenging source arises from the physiology of the hand combined with the lack of a physical surface on which to type. Without the physical resistance of keys, intentional finger movements can cause other fingers to move unintentionally, producing unwanted key activations. These events are known as coactivations, and eliminating them improves the efficiency of information transfer and improves user experience. Determining an effective method for identifying them and implementing this method into an existing statistical decoder is the aim of this work. The first step was to review a dataset of 24 people typing on a mid-air virtual keyboard with all 10 fingers in virtual reality for approximately 45 to 60 minutes. This was done to identify the circumstances in which coactivations occur. We found that the ring finger produced the majority of coactivations observed, as shown on the left. We also found that the majority of coactivations were caused by a finger lateral to the intended one. For example, for intended use of the middle finger, coactivations of the ring and pinky occurred most frequently, as shown on the right. The review was also used to identify an initial set of features distinguishing coactivations from intended activations, of which two are shown here. On the left, the time interval between activations, and on the right, the average correlation of finger velocities. In both plots, orange indicates coactivations and blue indicates intended activations. These features clearly show how coactivations can be identified and separated from intended activations. The features were then refined to retain the ones most suited to being implemented into an existing online system. These features were evaluated by training a neural network on a single feature and recording its performance. Low-performing features were removed, leaving a final set of 4: the velocity of the finger producing the current key activation, the finger depth of the previous key activation, and the interval and correlation between the current and previous key activations. 3 models were trained using the final features: a neural network, a support vector machine, and a naïve Bayes. The performance of each is shown here, with all models achieving a high level of accuracy in detecting coactivations. The neural network achieved the highest F1 score and so was chosen to be implemented into an existing statistical decoder. The existing decoder calculates the probability that an input character was intended and uses this result to make more accurate autocorrections. The model's coactivation prediction is incorporated into this probability, and if the prediction exceeds a certain threshold, the character was removed. An example is shown here. First, NOP is entered using the index, middle, and ring fingers. The user is trying to type the word notes, but has caused a coactivation with their ring finger and inserted the P into the input field. The coactivation module subsequently identifies and removes the coactivation before the remaining characters TEE are entered. Finally, the input is corrected to the desired word notes by the decoder. With the addition of this model, a reduction in character error rate by approximately 10% relative and 0.9% absolute can be achieved. This investigation has shown that identification and removal of coactivations from a text input stream can be completed with simple, lightweight features. 4 features have been identified that can aid the detection of coactivations. Combined, these features can achieve a detection accuracy exceeding 97%. The module integrated into the decoder also demonstrates how coactivation detection can effectively reduce character error rates.